Our review, our video reviewing the practice final. When we'll start with question one. Question one is going to be a product. We're going to use the product rule. And the first step is to decide what the first factor is in the product and the second factor. In other words, what two functions can we break this down into as a multiplication? Well, the first function is clearly x squared because the second is natural log of x, so that means that we identify the first function as f. We identify the second function as g. And I strongly recommend that this is what you do when you work this problem. Break those two down like that, and then take the derivative of each. Of course, the derivative of x squared is just 2x using the power rule, and the derivative of the natural log of x is 1 over x. And then we will use this form of the product rule that is shown on the handout that I gave you with differentiation and integration properties, and is also shown in the classwork packet. The easiest abbreviation is f prime g plus fg prime. So that's f prime, the derivative of the first function, 2x times g, the second function, which is just natural log of x, and then we add that to the first function, which is x squared, times the derivative of the second, which is g prime, which is 1 over x. Derivative of natural log of x is 1 over x. And the first term here is easy to simplify. All you really do is just remove the parentheses, which you didn't necessarily have to have there, but I put them there to emphasize that that's a separate function from the natural log of x. And then the second term is x squared times 1 over x. Well, x squared times 1 over x is x squared over x, and that simplifies to x. Now the second question is going to require the use of the quotient rule, and we do a similar thing that we did in the last question, and that is identify the numerator, the function in the top, as f. That's our f of x, and we identify the function in the denominator in the bottom as our g of x. Then we differentiate each of those, and so the derivative of e to the x is e to the x, and the derivative of g of x is 3x squared. So f is e to the x, f prime is e to the x, g of x is x cubed, and g prime of x is 3x squared. And here again is the way this rule is stated in the formula, the property sheet that I gave you, as well as in that section of your classwork packet, f prime g minus fg prime. And so that's f prime, the derivative of the first function, e to the x, times the second function, which is x cubed, minus, because this time it's a subtraction, minus the first function, or the f of x, which is e to the x, times g prime, the derivative, 3x squared. So that's our numerator. Then in the denominator, we square the entire function. The entire function is squared. So put parentheses around whatever function that is and square that. And what I've done here is I've applied the property of exponents, which says that this simplifies as this base raised to the 3 times 2. 3 times 2 is 6, so the denominator becomes x to the 6th. All I've done in the numerator is just change the order of these multiplications to what would be more conventional. The x, the factors that have x as their base go in front of the e to the x in both cases. So that's all I've done there is change the order of the multiplication. And then in the next step, I have factored the greatest common factor out of the numerator, which is just x squared, and the reason I did that is because that is also a factor of the denominator. So the denominator is x squared times x to the fourth. I factor an x squared out of both of these terms, and that leaves behind x and 3 times e to the x. And then the x squared, which is common to the numerator and the denominator, cancel out. And so my final simplified form of this derivative is at the bottom here, x times e to the x minus 3 times e to the x over x to the fourth. And finally, the last question on this first page, question 3, uses a chain rule. Now, if your question on the exam is a radical like this, you're going to want to convert that to an expression with a rational exponent. The cube root of this would be this function that's inside raised to the 1/3. The fourth root, if this was a fourth root, would be this entire function here raised to the 1/4. And you do that so that taking the derivative is much simpler. Now remember, when we use the chain rule, we want to identify what's the sort of outer function, what's the bigger function that the other function is plugged into. And so that's whatever this is in these parentheses raised to the half. And so I've indicated that here with just box. So we're not going to touch what's inside those parentheses in the first step. We're going to differentiate the sort of the outside function and leave what's inside alone. And so we use the power rule, multiply the 1/2 around to the front here, and subtract 1 from 1/2. Well, 1/2 minus 1 is negative 1/2, and so this part of the differentiation gives us 1/2 times box raised to the negative 1/2. In the text and possibly in the classwork packet, there's a substitution where you don't ignore this in the first step, or you call it u, and then you substitute u back in. And if that works good for you, then by all means do that. But now I've differentiated the outer function, and what I need to do now is differentiate what's inside. So what's inside the outer function is x squared plus 2x minus 1, and when I differentiate that, the derivative of that, just using the power rule, is 2x plus 2. I then multiply that derivative times whatever I got when I differentiated the outer function. So this expression inside the square root stays the same, and after I after I differentiate the outside function, I then multiply that times the derivative of the inside. So I hope that's clear. There's not a whole lot of room on the test to complete this question. There's not a whole lot of room to write because there's very few steps. So it should be easy enough to do. And I think I'll cut the first video off at this point, and the next video we'll pick up with question 4.